what you're going to do is you can have your periodic table out in front of you from page 141, but I think the one that you got is the better one of the two, because you can see the numbers, and the numbers are what we're going to need. We're not going to start with the periodic table first. Module 4, we will end with the periodic table, but Module 4, which I have not yet pushed out to you guys, I will push it out tomorrow. Module 4 is it's actually modules 4, 5, 6, 7, 8, and 9. Those all have to do with chemistry. So module 4 first talks about matter, and then we're going to get more into the periodic table. So yeah, it's a lot. It's chemistry. I absolutely love chemistry. This should be fun for us. Okay, so if you can, please type in the chat, what is matter? Not what's the matter, but what is matter? What do you think matter is?
I know what it is.
Okay, hang on a second, Johan. Let's give everybody a second to type it in the chat. What is matter? Okay, go ahead, Johan. What is it? Johan, are you there? I'm going to pause. Matter does make up everything. Everything is made of matter. Now, you guys know, and you've learned already in the past, that matter makes up everything. Your pencil, yes, yes, everything. Even you are made up of matter. So, you know, when I ask you what is matter, I'm not asking you what's the matter. I'm asking you what is matter. Now, there are different phases of matter that you guys have learned about. Type in the chat any of those phases of matter that you've learned, and think about going back to like 2nd grade. Yes, your brother is matter. But what are the 3 phases of matter? And you might know 4. Yes, great. Solid, liquid, gas, and some of you put plasma. Yes. So those are the 4 that we're gonna recognize as the 4 phases, but we're gonna talk about solid, liquid, gas. Good. Okay. So let's talk about let's think of a pot. You're going to have a pot, and you're going to put it on your stovetop. I'm going to put 10 ice cubes in my pot. Those ice cubes are the solid phase of water, right? And I'm going to turn the flame on underneath the pot. Okay. When I turn the flame underneath the pot, what's going to happen to my solid water, my ice? Not yet, Susie. It's going to turn into a liquid first. Okay. So we have a solid. The ice is solid water. It's going to turn into a liquid, which is your liquid water. Then after a period of time, maybe that water is going to boil, and it's going to turn into a water vapor. Yes, it's going to then evaporate, which becomes our gas, right? So it goes from a solid to a liquid to a gas. Yes. But where does the gas go? Like, what kind of gas? What is it? When we say that the water is evaporated, where does it go?
To the cloud.
To the cloud. Which cloud? The iCloud?
Up into the atmosphere.
Into the atmosphere. It goes into the whole atmosphere, right? It goes up into the air, in the atmosphere, and those water droplets cling in onto other atoms in the atmosphere. And then what happens is, over a period of time, that water vapor, whether it's from boiling water or from the oceans, the rivers, the lakes, the streams, all that water builds up in the atmosphere to a point where there becomes too much water in the atmosphere. They do form clouds and then it rains. What else can it do? What are other forms of precipitation besides rain? Snow, hail, good.
Sleet.
And sleet. Yes, absolutely. So those forms of precipitation, once the atmosphere becomes too full of that water, it comes out of the atmosphere in the form of precipitation. And you guys should have learned the water cycle, right? So it's going from the groundwater, it's going from the oceans and lakes, it evaporates, it goes into our atmosphere. When there's a buildup of too much liquid or too much vapor in the atmosphere, it will wring itself out and it will either rain, sleet, snow, or hail. So we've talked about solid, liquid, gas, and evaporation, right? There's two other words that I want to talk to you about. Let's say I take that, and today's a perfect day to do this. Let's say I have that pot of boiling water and I go and I put a lid on it. What's going to happen to the water vapor then if I put a lid on top of the pot? It traps it.
It stays inside.
It stays inside. It builds up on the lid. What is that called when the gas goes up and hits the lid? Condensation. Good job, Austin. So the liquid is going, or the vapor is going to condense back into a liquid. So when you pick up the lid of the pot, you'll see droplets of water on it because the pot lid is cooler than the steam that's hitting it. So it causes it to condense and make those droplets of water again. You can try this, and today looks like a really good day to do this. Your parents aren't going to be happy, but tell them it's a science experiment, okay? Go outside to their car, and you're going to sit in the car, and you're going to take your face and you're going to put it close up to a window, and you're going to on the window and then right in it. Because what's happening is when you breathe out, you're breathing out water vapor. And when that breath hits the window is warmer or the window is colder, your breath is warmer, and the water vapor that's coming out of your mouth is the temperature of your breath, and it hits the cold window and it condenses and it creates little droplets. So yes, if you did that as a little kid, and even if you did it now, your mom would probably get mad at you, but tell them it's a science experiment. Tell them it's a science experiment, okay? The other way that you can do this, I see Daniel literally right now. So I see he's got glasses on. I have glasses on. A lot of people clean their glasses by and then wiping it off. The reason why they do that is because they're adding moisture to the lens from their breath that they're able to wipe off, okay? You can do it on your sliding door, absolutely. Yes, so any way you want to do it, either way, whatever glass that you do it on at home, you're going to need to use Windex to be able to clean it. Because if you this is why your mom would get mad at you, is because if Arturo, if you did that and you wrote into it, whatever you wrote in there would stay unless you use like a real glass cleaner to clean it off. If you just tried to rub it off with your shirt or whatever, it would make a big smudgy mess. So that's why they would get angry. But tell them it's a science experiment now. Tell them that Miss Cook said you can blame me on it. But when you do write into the mist, do something appropriate. Don't make nasty drawings or anything, okay? So yeah, and if you think about like on a hot day, if you go outside on a hot day with a glass of ice or ice cold water, the glass itself becomes very wet on the outside of it, right? That again is condensation. Now we live in Southern California, so there's generally not that much humidity in the air. And when they talk about humidity in the air, they're talking about that water vapor. So because there's not a lot of humidity in the air, or if you would go to Vegas, there's not a lot of humidity in the air, it's very dry, you're not going to have the oversaturation of the atmosphere because there's no vapor in it or there's no water in it to be able to be wrung out. But if you go up north, that's where it, like, you know, you go to Tahoe or you go to Mammoth, you go to Oregon, you go to Washington State, you're going to have more weather and snowfall. Yeah. Okay. So now we've talked about solid, liquid, gas, evaporation, condensation. There's one other phase. It's not a phase. It's how the objects move between the phases. So we can go from solid to liquid, liquid to gas. We can go from gas back to a liquid through condensation, right? We can go from liquid to a gas with evaporation. There's another type of movement between the phases, and that's called sublimation. Have you heard of the term sublimation? Sublimation. Anybody? Sublimation? Sublimation is really cool. What happens, yes, Gibbles, what happens with sublimation is that you're going from a solid directly to a gas. You completely skip the liquid phase, okay? And we're going to talk about Mac. That's the second time you asked about fire. Hang on. Yes, Drake. Okay, so dry ice might be something. Hang on a second, Susie. I see your hand. Dry ice might be something that you've heard of. This is a perfect time of year for dry ice because it's Halloween, right? So when you use dry ice, it goes from a solid directly to a gas. And a lot of people will put dry ice into like a drink mixture in a cauldron. And what happens is when that dry ice is going from its solid phase into a gas phase, that gas looks like the steam coming out of a cauldron, like a witch's brew. Yeah. So people use dry ice for that. Dry ice is really cool. You have to be careful when handling dry ice because it is such an extreme cold temperature that the ice can actually burn your fingers like frostbite. Yeah, it's fun to do, Paige. What I'm going to say, if you want to do a dry ice experiment, I have a couple that you can do. Dry ice, like we said, is a solid and it goes directly into the gas phase. If you take a piece of dry ice, and of course do this with your parent, I think they sell it at Smart and Final. I think I know that they sell it at Smart and Final. I don't know where else, but I know they sell it at Smart and Final. Get a piece of dry ice. And if you have, you guys probably don't know what regular film looks like because you're so used to using digital cameras or your phone to take pictures. But the older cameras, and they're really not that old, the older cameras used to run off of film, and the film would come in a little canister. The canister usually was black with a gray lid. And it kind of looks like a medicine pill bottle that you would get from CVS, but the difference is how the lid goes on. The CVS bottles will not work for this, the medicine bottles, because you kind of have to screw them. They're childproof. The bottle for the film canisters, what it is just a lid that pops on. So if you don't have a canister like that, maybe you have a small Tupperware container, or one of those containers that has a lid that pops on. Take some dry ice, put it into the container, and put the lid on it. When you do that, oh, Santi, you do. That's cool. Do you have the film canister, Santi? If you have the film canister, take it out, please. But so you take that piece of dry ice, you put it in the container, you put the lid on it. Eventually what's going to happen is that that dry ice, that solid, is going to turn into a gas. And gas needs a lot of room for particles to move about, okay? So when you have a solid, your particles are really close together. When you have a gas, your particles are spread throughout everywhere, just constantly bouncing off of one another, wanting to move around, wanting to get out of the space that they're in. So when this solid, with all of its compacted parts, goes into the gas, what happens is that gas wants to escape. So you could put the dry ice in there, you put the lid on it, and you wait a couple of minutes. After a while, the gas is going to build up so much pressure in there that it's going to pop the lid right off. And it's going to do it. It's going to do it pretty quickly. Like, you don't want to put your face near it because you could get injured by the lid that's coming off of the canister or whatever it is that you have. So that's cool with dry ice. Santi, do you have the film canister that you could show us? I don't know if he's there. Yeah, okay. So do me a favor. Oh, there you are. I see you. Guys, take a look in Santi's picture. You can see it's a clear canister. Hold it sideways. Okay, see that? So what you do, what you're going to want to do, Santi, if you do this with the dry ice, is, do you have film inside of there right now? Can you open it up, take the film out? Okay, so there's a canister. It's a clear canister. When I used them, they were black, but that canister has a lid, and the lid just pops on. So you take a piece of dry ice, you put it into that canister, put the lid on it, step back a couple of feet, and wait for the dry ice to hold it closer to the camera, please, Santi, because people are still trying to look. Yeah. Thank you, sir. You're going to stick the dry ice in there, and the lid is going to fly off because of the amount of pressure that you're putting, that the gas is building up in there. Have you ever taken a soda bottle and shaken it, and then you open it and it's psh, everywhere, right? You give it to your friend. I'm like, hey, I want you to have this soda, and right in their face. That's all the gas that's building up in there. It needs a place to escape. And at this point, the gas escapes, but it takes all the liquid with it, and it splashes your friend in the face. Yeah. Same thing's going to happen with that film canister. Okay, so now we have solid, liquid, gas, we have evaporation, we have condensation, and we have sublimation. Good? Okay. 3 phases of matter. All right, let's go to our periodic table. This is where it gets exciting for me. So yes, you have your periodic table, and you're going to hold it, for me, you're going to hold it vertically and on the back side, because we're going to draw. I'm going to tell you what I want you to draw on here, and we're going to take some notes. Okay, if you look on the front, in the center, it gives you a key, right? I want you to, on the back, and you'll notice I did not draw it very large. I just drew it up at the top. A box with a capital N and a lowercase a, and the number 11 above it. And that's exactly what's on the front of the periodic table. Yes, Kaya, you can easily do that. We talked about that the other day, Mentos in soda. And I did multiple experiments. I got all different types of soda. I got diet, regular, orange, 7-Up, root beer to see which one worked the best. But what's happening is that the gas needs a place to go. The Mentos is causing the gas to erupt, and the gas needs a place to go, so it takes all the soda out with it.
I remember I did a Coke and Mentos experiment.
It's super fun.
Yeah.
Super fun. You had your hand up earlier, Susie. What can I do for you?
It was about the dry ice thing, like how to do
Oh, okay. Thank you. You were being respectful and raising your hand. I appreciate it. Sometimes you're just on mute and blurt it out. That's okay. Okay. So now we have the number 11 and we have Na in a box. And what it tells us on the front is that it's a key for how to read the periodic table. And it does have some words on there, but I'm going to tell you specifically what those words mean, and you're going to have to write this information down. I will put it in the chat because I don't expect you to write it as fast as I say it. So the first thing that I want to talk about is on here we have the letters capital N, lowercase a, and beneath it we have a word. What is the word? It's on the front. What's the word below capital N, lowercase a? Type it in the chat. Good, sodium. Okay. Yes, okay. So the reason why, that's fine, I don't care about your spelling, I know what you're trying to say. The reason why we have the letter Na is because it is called our element symbol. And the element symbol are the letters that represent an element's name. Okay, so the element symbol are the letters that represent an element's name. Okay, so now you already told me that the name of Na is sodium. Why is sodium Na? Like, I don't get it. What does Na have to do with the word sodium? Daniel shrugs his shoulders. Anybody? Oh, it's chemical makeup. It's all sodium. There's nothing else but sodium and sodium. If I said NaCl, that would be a chemical makeup because that's sodium chloride, and we'll talk about that later. But it's just Na. Okay, its contents are all sodium. Yeah. So why would somebody say, oh, let's name sodium, let's give the element symbol for sodium Na instead of S or SO or SU? Why do you think? Or if you don't know, shrug your shoulders, type in IDK, yeah. Like I'll tell you, for instance, iron. Iron is an element, and iron has the abbreviation Fe. They were lazy because they already have SO. Yeah, they do have SO, but what number is SO, Paige? They were running out of, okay. The numbers are very important. You know how sodium has the number 11 above it? That means that there are 11 protons in it. It also tells us that it was discovered, one of the first ones discovered. So they could have used SO because SO, yeah, it's all the same element, Na. I'm going to tell you guys why. I already said that iron is Fe, gold is Au, silver is Ag. Some of them don't make sense. Like, why would you put that? Potassium is the letter K. K for potassium, right? All these weird things. Science is based on, instead of banana, canana. Science is, a lot of the words in science are based on the Latin language. So the word for iron is ferrous, and that's Fe. The word for sodium has Na in it. So they're using the Latin derivative, and they're taking the abbreviation, the element symbol, from the Latin word for that word or that element, okay? So some of them you're just gonna have to commit to memory. You do not have to memorize the whole periodic table. You will always have access to use it. All right, but you do have to know how to use it. So I'm going to tell you step by step how we use this periodic table and figure out what's on it. So first off, our element symbol is Na. Na represents sodium. Above Na, we have the number 11. That is our atomic number. And I'm going to tell you what to do with it in a second. The atomic number represents the number of protons in an atom. Okay, so again, there you go, natrium. So that's the Latin word. Thank you, Gibbles. The atomic number represents the number of protons in the nucleus of an atom. Okay, so what I did, and my son borrowed my highlighter, I've got it back. I've written up here like this, okay? I'm just drawing little lines, and right below it, I wrote my atomic number, okay? The atomic number, and you've got the definition. Atomic number is the number of protons in the nucleus of an atom. So now we know that an atom has a nucleus, right? And there are subatomic particles in that nucleus, including protons. There are also other subatomic particles in the nucleus, and those are neutrons. If you look at the number beneath the word sodium, there's going to be a number there with a decimal point. That tells us the mass of the nucleus of an atom. The number beneath the name of the atom itself is going to tell us the mass of the nucleus of the atom. So we call that the atomic mass. Tell me what the atomic mass of sodium is, please.
It is, oh wait.
Good, 22.99. Now, when we talk about atoms and their atomic mass, we are always going to round the atomic mass to the nearest ones. Okay, we don't want to use decimals, so it's going to be to the nearest ones. If I take 22.99 and I want to round it to the nearest ones, I have 23. Okay, so now it's saying, I'm telling you that the atomic mass that they have there is 22.99, but when it comes to doing mathematics in here for science, you're going to take that atomic mass and you're going to round it to the nearest ones. What is the atomic mass? The atomic mass, and I'm going to write another definition right underneath atomic number. The atomic mass the amount of protons and neutrons in the nucleus of an atom. Okay, so now I've given you a new word, and that is neutron. Amount of protons and neutrons in the nucleus of an atom. Okay. Let me know if you need me to slow down. Okay, so you have the atomic number and the atomic mass, and you've got it written in your box like it is on the front. So now we know that sodium has an atomic mass of 23. It has an atomic number of 11. And what did I tell you the atomic number represents? How many? See I'm just showing you what it looks like because I know it's really small, but you can get all the information from the chat. Okay. Yes, Gibbles. The atomic number gives us how many protons. The atomic mass tells us how many protons and neutrons there are. So now I can do a mathematical equation. If I know that there are 23 protons and neutrons, and I know that it has 11 protons, how many neutrons does it have? Write the math equation in the chat to figure out how many neutrons there are. If I have 23 in total and I have 11 protons, how many neutrons do I have? Write the equation. You're right, but other people may need to see how you got there. Cheyenne, feel free to answer. Dylan, Luke, Mac, Wyatt, Allison, Hazel, David. Okay, yeah, 23. I have a total of 23. And if I take away 11, that means that I have 12 neutrons. So far, so good? Okay. I'd like you to do me a favor. Thank you, Cheyenne. I'd like you to do me a favor. Flip over to the front of your periodic table. Find element number 17. Its atomic number is 17. When you find what 17 is, type it in the chat. Good, good. And I chose chlorine on purpose because NaCl is sodium chloride, which is also known as table salt, right? The salt that you put in a shaker is NaCl. It's made out of sodium and chloride. So you have, and chlorine. So we have, I want you to look at chlorine. You know that the atomic number for chlorine is 17. Tell me how many neutrons are in chlorine, but write the mathematical equation in the chat. How many neutrons chlorine's number 17, which means you know that it has 17 protons. The mass of chlorine, the atomic mass of chlorine. Yes, Luke. Yes, Gibbles. The atomic mass of chlorine is 35. If the atomic mass is 35 and I have 17 protons, therefore I have to have 18 neutrons because protons and neutrons make up what's in the nucleus of the atom, right? So now we know how to figure out atomic mass and the atomic number, how many protons, how many neutrons. The last thing that I'm going to talk to you about right now is electrons, because there are 3 subatomic particles. And those 3 subatomic particles are protons, neutrons, and electrons. So let's put on here 3 subatomic particles are protons, neutrons, and electrons. Now, I told you that protons and neutrons are found in the nucleus of the atom, right? Protons and neutrons make up the mass of the atom. The electrons are not found in the nucleus. Only the protons and neutrons are. The protons and neutrons are what have the most mass, okay? Protons, neutrons, electrons. Where are the electrons? If I have protons and neutrons and they're found in the nucleus, what are my electrons doing? Have you ever heard of the character Pigpen from Snoopy? The kid that carries the blanket behind him that has the big dust cloud. I don't know if he has a blanket. Maybe he just walks around and there's a big dust cloud following him, right? Electrons are like that, where you have the nucleus of the atom, and then around the nucleus of the atom in a big cloud are electrons, okay? Those electrons, the reason why I'm talking to you about electrons is they have very little mass. So what's the importance of electrons? Each one of the subatomic particles I told you has a type of charge to it. Protons are positive. Electrons are negative. Neutrons are neutral, which means that they don't have a charge to them. So we're going to type in here, protons are positive, neutrons are neutral, and electrons are negative. Okay? Protons positive, electrons negative, neutrons neutral. Now, you know how we said that sodium has the atomic number of 11? It also tells us that it has 11 protons. Besides having 11 protons, it has 11 electrons. So the atomic number not only tells us how many protons there are in an atom, but it also tells us how many electrons there are in an atom. Okay, atomic number is the number of protons and electrons. Oops, I mistyped. And the atomic mass is the amount of protons and neutrons in the nucleus of the atom. Okay, so the first number that you see up on the top is going to tell you how many protons and how many electrons there are. And if you read the periodic table of elements and you look at it, you could read from left to right. Hydrogen is 1, helium is 2, then it's lithium, and it goes on throughout the whole 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, until you get up to 118. 118. They have 103 listed on here. There are more, but that's all you need to know for us right now. Does anybody have any questions? This is a lot of information at once. I am going to push out your module 4 tomorrow. The beginning of the week of module 4 will be next week, and it's all about matter, solids, liquids, gases, condensation, evaporation, and sublimation. All right. So we talked about that already. If you need to revisit, I'm recording this, so we'll post it on my YouTube channel if you want to revisit it. If you need to take more notes or what have you, you'll be able to see it. Yeah, it's super fun, Gibbles, especially when we start talking about food.